All right, how is it going, guys? It's been a little while, but I have been working on some things that I would like to show y'all. So, uh, for those who don't know, this year, the main class I kind of took was like AP Physics, AP Chemistry, AP Calc BC, right? And especially AP Calc BC and AP Chem, I kind of really fell in love with. And I think I have a personal way of teaching that might be easier than how the school is going to explain it. And especially with AP Calc, where derivatives and integrals come in, you really have to learn it intuitively. If you just memorize everything, class is going to be hell for you. It's my personal opinion. So, today I have started a personal project, and that's writing a math textbook that is especially for the AP student. Now, if you're watching this, it's probably still in the works right now. But if you're a couple months later, and you're watching this, just hit me with the message or hit me with the comment. I'll probably send it to you for free. But I want to get it published and everything. I just think it's a good way for me to practice my math and to also teach others based on how I think about calculus, which is just a little different than how um, the schools teach it. So let me zoom in real quick and we can start looking at this. So here's how I define. So we're gonna start with unit one, right? Which is limits in continuity, and this is kind of the basis of how we learn derivatives. So this is kind of not exactly the main focus of calculus, but kind of like a prerequisite you need in order to learn what a derivative is, which is still pretty important, but it's not something that you need to focus terribly long on. And the limit, I think, is a fairly easy concept. It's basically saying, as we approach an x value, what would the y value be? So as we get closer and closer to a given x value, what would the y value approach then? And that resulting value would then be its limit. And limit notation is written out like this, where it just goes, you've probably seen this somewhere, it just goes, this is the function, right, that you want. And it's basically saying, as x approaches a constant a, or just any number, say like 3, 4, whatever, as x approaches a on this f of x function, what would the y value approach? And that answer is our r value, which is our answer for that limit. And another thing to note is that as x approaches a from both sides, so from what I mean both sides is, say we have a parabola, and it needs to approach from the right and the left side. They have to be approaching the same y value. Now, if they don't approach the same y value, then that given limit does not exist because it goes to different values. So we mark that as D and E. So say, for example, a graph kind of goes like this, and then there's a gap here, and it goes like this, and then say this is at x equals like 4. So as so how we write this out is limit as x approaches 4 of this f of x, it won't exist because from the left side it's approaching one value, from the right side it's approaching a different value. That means if they approach different values, it doesn't exist because the limit is approaching two different values. So let's look at the practice. The limit as x approaches 0, I don't like this brush, so I'm going to make it a little smaller. As it approaches 0, so that's this here right here. On the left side, it approaches 1. On the right side, it also approaches 1. So this answer would be 1. All right, perfect. That makes sense. Just erase all that. This makes sense. Next, as it approaches 1. Now, even though there's a hole here, that means it doesn't exist as... That means f of 1 does not exist. That doesn't matter because the limit is not what it's defined as. The limit is what it approaches. And as it goes from the left and as it goes from the right, it approaches 1, although it never reaches y equals 1. It approaches that value, which is why it's important. That's what we care about. It approaches 1 because it never touches 1, but it'll approach it. Next, y equal as x approaches x equals 2, from the left side it approaches was 2.5, right side it approaches 4, approaches different values, right? What do we say? That does not exist. That's fairly easy. This is the primary concepts of limits. So that should be pretty good for this video.